section. And again, the only reason I'm doubling this up because it's pretty much the same stuff, just a couple different things. There's a little bit thing different in the criteria. When we go to do our normal CDF, it's a smidge difference for the standard deviation. That's pretty much the only difference. So it's just paying attention. Am I dealing with means or proportions? Depends on how I need to set up some of that information. And then tomorrow we'll practice a bunch of this stuff in class. So as we look at this next section, we're basically, instead of dealing with sample means, we're dealing with a sample proportion is what we're dealing with. So we're dealing with p hat. Remember, p hat is basically your x divided by n, your number of individuals divided by the total number is what it is. Now, when I'm looking at a sampling distribution and this is supposed to be p hat. I couldn't get that stuff to line up. P hat. Our sampling distribution is approximately normal. It's approximately normal if this occurs. If I have n times p times 1 minus p, is it greater than or equal to 10? If that's the case, then I'm approximately normal. If n times p times 1 minus p is not greater than or equal to 10, then I'm not normal, which means I can't use that normal CDF feature to find my calculations. So the mean of our sampling distribution is just whatever p hat is. So mu sub p hat. Mu sub p hat is whatever our population proportion, whatever that is. And then our standard deviation is now this formula. Instead of being like standard deviation over the square root of n, it's actually the n times 1 minus p divided by n. So it's a different little formula there. Have you guys been tweaking your formula page for your final? Have you been adding little things here and there as we do different formulas, adding to that page? You want to make sure you're doing it. That way it's not like cramming it all at the last time. Remember, you get the front and back of a piece of paper for your final. So this is where I'd start adding some of these. I'd use a title of, sampling distribution for p hat. And I would put down these criteria and I'd put down this thing as a formula. That way you have those things to jog your memory when you're in the heat of the test. Same thing for the means. I do a separate one for means. I need to make sure this occurs, and so forth. Okay. Just giving you a little advice. Creating it as we go now is a lot easier than trying to do it the week of the final. So they asked us to describe the sampling distribution of p hat. Assume that the size of the population is 25,000. There we go. All right, so a small town there. So what can we say about the sampling distribution? All right, p is 0.4. So they're telling us that the population proportion is 0.4. Well, what can we say first? Mu sub p hat is equal to whatever p is. So that means that it's equal to 0.4. So the mean of the sampling distribution, that's what mean sub p hat. The mean of the sampling distribution of p hat is equal to 0.4. Now, let's check normal clause. Is n times p times 1 minus p, are we greater than or equal to 10? If that's true, then I can say it's normal. So is 500 times 0.4 times 1 minus 0.4, are you greater than or equal to 10? All right, so that's 500 times 0.4 times 0.6. And we'll grab our calculator and make sure we do that math correctly. So 500 times 0.4 times 0.6, that's 120. So 120 is greater than or equal to 10, so approximately normal. When I'm dealing with proportions, it doesn't matter about the sample size. I got to do the multiplication part. I got to check that clause. If it's greater than or equal to 10, then it's normal. All right, so for number 8, again, mu sub p hat is 0.7. Whatever p is, p hat is the same. Now I have to check the normal clause. Let me see if I can make that a little bit smaller. There we go. So as I zoom in here, 200 times 0.7 times 0.3. Are you greater than or equal to 10? All right, let's see. 200 times 0.7 times 0.3. 42. 42 is greater than or equal to 10, so we can say approximately normal. Sorry for the crazy 4. All right. Sample size is 1,000. So first, mean of the sampling distribution p hat is 0.103. That's the first thing I need to say. That's the mean. What is it now? What is the is it approximately normal? Let's see. So is 1,000 times 0.103 times 0.897. Are you greater than or equal to 10? So it's 1,000 times 0.103 times 0.897. Okay, we're good. 92.391 is greater than or equal to 10, so we can say approximately normal. And then the last one, and then we got to go back and then we got to do one more thing for each of these problems, because we've gotten some of the stuff. We told it that it's normal. We found what the mean is. What have I not calculated? Anybody notice what I have not calculated yet on the 3 problems? I haven't calculated the standard deviation, have I? So we're going to go back there and find the standard deviation for each case. Again, we can find the standard deviation if it's normal. If it's not normal, I can't do it. Okay? There's no point to it. So now as I look at this, I have 10 times 0.84 times 0.16. Are you greater than or equal to 10? Again, I know mu sub p hat is equal to 0.84. So now 10 times 0.84 times 0.16. Yep, so we're good. So they didn't give us any curveballs here. So approximately normal. Now all I want to do is go over and find the standard deviation for each one. That way we have it for when we do like normal probability stuff. So what is standard deviation sub p hat for the first one? Well, according to the formula, I can do the square root of p, 0.4, times 1 minus 0.4 over my sample size of 500. Now, we can type that in the calculator just the way we see it. We can go in there and say second x squared and then alpha x to give me a box in there, and I can type in 0.4 times 0.6. On the bottom, I type in my 500. And this tells me that the standard deviation of p hat is 0.0219. So you're looking at like 0.022 is what we're looking at. Any questions so far as we're doing it? Again, for each one of these, that was number 7. We can do the same thing. So for number 8, we would go through and say, all right, I know it's approximately normal, so I can go ahead and calculate this thing.
So we can say the standard deviation of p hat would be the square root of 0.7 times 0.3 over 200. So now it just becomes a calculator activity. 0.7 times 0.3 over 200. And I get that one has a standard deviation of 0.0324. Do you need me to do 9 and 10? No. You want to do the... I only have one example here left. It was actually doing the probability stuff. Because, again, the activities, the two lessons are so closely associated or correlated with each other. It's just, hey, instead of dealing with mean and standard deviation, I'm dealing with p hat, and I'm dealing with a different formula for the standard deviation that I got to go through and calculate. So it was just, they were very similar in activities. As I look at my next example, it says a simple random sample size n is equal to 75 is attained from the population. The big population is 10,000. They tell us that capital P or population P, the parameter P is 0.8. So as we do things, we can say first that mu sub P hat is equal to 0.8. And then now if I do 75 times 0.8 times 0.2, are you greater than or equal to 10? So 75 times 0.8 times 0.2 is 12. Ooh, that was close. 12 is greater than or equal to 10, so approximately normal. That was a close one. All the other ones, we were fine. That one was close. We were close. But again, it's okay to be equal to the 10 as well. If we drop to like 9.999, we would say we're not approximately normal. Right? As soon as you drop below 10, and we wouldn't round to make me be equal to 10. If the calculation comes out to where it's less than 10, then we would say we're not approximately normal. Even if it's like 9.999. Okay? So we don't have that happen that often, but it could theoretically. So it's approximately normal, so I can go ahead and do the standard deviation of p hat, square root of 0.8 times 0.2 over 10,000. So I'm going to go ahead and grab that decimal real quick. Second that, give me that. 0.8 times 0.2 over 10,000. This one said 0.004. And then now I'm ready to do these probability stuff. What is the probability that p hat is greater than 0.84? What is the probability of obtaining x equal to 63 or more? All right, so now when I look at the 0.84, if I look at 63 divided by 75, just real quickly, 63 divided by 75, that's the 0.84. They went ahead and converted that for me. That's where they put 0.84 there. And so I'm going to use 0.84 in my formula. So I'm going to do a normal CDF. My lower bound is 0.84. My upper bound, again, I like doing something really big. My mean, again, based on this problem, our mean was 0.8. And our standard deviation of p hat, we said, was 0.004. And so now we go second vars, normal CDF. 0.84 is my lower bound. Upper bound is something really big. 0.8 is my mean, and my p hat, my sigma p hat is 0.004. And all right, so that one, let's see. 7.7703 e to the negative 24. Now, what does that mean? What does that mean as an answer? Anybody can tell me what that means as an answer? Is that a high probability or is it a low probability? It's a low one, isn't it? Because that negative 24 means I have how many zeros technically in front? Yeah, 23 zeros. So if it happens, it'd be pretty unusual for it to happen. Okay, based on that information, based on that sampling distribution, to get a p-hat that is greater than 84%. It is not likely. Right? It is super unusual. All right. What would that mean if this was like a real situation? What would I do if that did happen? I go back and double check my calculations. Did I do everything right before? Make sure they're not. Because again, that's a super small decimal. So I double check and stuff and say, you know what? I did all my stuff right. And so therefore it wouldn't happen. It shouldn't happen. It'd be one of those things like, I'm trying to think of a real world example of something that has such a low probability like that. You can't use a lottery because it is possible that you can win the lottery, but the probability is really small. It could be Mr. Stevens could fly. That's something, it's gotta be something that's super outrageous. So, again, both of those assignments are live. I have them, I think, due, who's seen when the due date? Is it Friday? Then we're gonna take a quiz Thursday, so I haven't set that thing to be due Friday. To have both assignments due Friday. And then I think the next chapter set of that we're doing, the proportions, those assignments are due right around somewhere that first week of April, because that's when we're going to take a test right where my daughter's due date is for doing a C-section.